Welcome. We're going to talk about intelligence today. My name is Björn Liljeqvist. I am the chairman of Mensa International, and I'm joined today by Dr. Russell T. Warne, former associate professor of psychology at Utah Valley University, USA. He's the author of this amazing book, In the Know, Debunking 35 Myths about Human Intelligence. He was also the 2019-2020 recipient of the Award for Excellence in Research from the Mensa Education and Research Foundation. Russell, we are very happy to have you with us.
Thanks, Bjorn. I'm happy to be here.
Is it a good thing for people to know their intelligence, in your opinion?
I don't think it's necessary for everyone to know their exact IQ score, like a lot of Mensa members might, but it's probably a good idea for people to understand their abilities and their limitations. That way we don't try to have someone with an IQ of 90 trying to become an engineer. On the other hand, there's a lot you can understand about the world if you understand that, for example, a Mensa member might be much more intelligent than average, might be able to grasp abstract concepts better than large chunks of the population. And there's advantages to knowing it regardless of your exact IQ level, yes.
So intelligence in itself, I heard a quote that it is the greatest achievement of the science of psychology over the last 100 years. How so?
Yeah, I believe that there's several versions of that. Several psychologists have said that. But yeah, the study of intelligence, it's probably one of the strongest branches of psychology. We had in the 2010s in psychology a replication crisis where a lot of research that was fundamental to different topics and was important to different areas, especially social psych, was found to not replicate. When scientists would try to do the study again, they wouldn't get the same results, which is a foundational aspect of science. You need to be able to replicate the results. Otherwise, they're probably not real. Intelligence research escaped that because the quality of the methods are very high. And then when you look at the substantive information, the substantive knowledge we get from that research, it's very practical. It reveals a lot about society and a lot about individuals, and it has a lot more explanatory power than the vast majority of concepts in the social sciences.
So you could say that we know that there is such a thing as intelligence. Intelligence is real, and we know more or less how to measure it in people.
Yes, definitely. We know how to measure it. Mensa members are very familiar with intelligence tests. Some people call them IQ tests, but I prefer intelligence tests. I explain that in the book. And these tests are some of the best design psychological tests out there. They're way stronger than, for example, most personality tests, and the technology's been around now for over 100 years to produce IQ scores, and they're shown to be very predictive of many life outcomes. And like I said, it's an exciting area to be part of.
Is intelligence just one thing, or can you be intelligent in different ways? I know that this is one of the myths that you address in your book, like the idea that you can be having intelligence for using your hands or playing music, but it isn't quite so, if I understand correctly.
Yeah, you do. There's global general intelligence, and that's this ability to engage in abstract thinking, to engage in problem solving that applies to multiple contexts, multiple situations, multiple stimuli. Hence why we call it general intelligence. And there are different manifestations people can have of their intelligence. This is especially true when you talk about specific disciplines. I don't know anything really about chemistry beyond what a middle school student can know. And so when trying to apply my intelligence to chemistry, I fall flat on my face pretty well. But in specific areas where I do have training like statistics and social science methodology, I do quite well because there's been specific training that helps me out. But if I had equivalent levels of training in both fields, I would probably do more or less similarly in both of them. But intelligence is not the only cognitive ability out there. And I'm sure you see this among Mensa members, where some of them are very strong verbally. Maybe they can speak 8 or 10 languages or more.
Yes.
Other people are more strong in mathematical or nonverbal reasoning, spatial reasoning, being able to imagine complex shapes in 3 dimensions, for example, navigate in unfamiliar territory. And so we do have things like spatial ability and verbal ability and mathematical reasoning that can supplement people's intelligence. But those things aren't global. They don't apply as universally as general intelligence does. But they are still useful, and they can help differentiate and explain why 2 people with IQs of 150 can have very different areas where they excel or struggle in.
You list 35 distinct myths about intelligence that you then proceed to debunk, as they say. That, for example, that intelligence is just whatever we measure on an intelligence test, or this idea that there are multiple intelligences instead of intelligence being one single thing. One of the more surprising myths that you list here is, it says measuring intelligence is difficult. Well, I would have thought measuring intelligence ought to be difficult. But you say that no, it's not.
Yeah, compared to other psychological tests, it's actually quite easy to measure intelligence. Any task that requires some sort of cognitive decision making, reasoning, any task like that will measure intelligence to some degree. Some of them are better measures than others, and that's why even though different Mensa members might be taking different intelligence tests to qualify, sometimes very similar tasks are on them, because psychologists tend to like to use the tasks that measure intelligence the best, and they tend to gravitate towards some of the same tasks. But really any task, even very basic reaction time tasks, are measures.
Could you give an example? What would that be? Like click this button when the light turns on?
Yeah, we call that simple reaction time. You're told, like you said, when you see the light, press the button, or when you hear the sound, press the button. And it's on the level of milliseconds or fractions of a millisecond, not conscious enough that people would realize it. But smarter people tend to have faster reaction times. We can make reaction time tasks more complex. For example, I have 2 stimuli. When the red square appears, press this button. When the blue circle appears, press that one. And so it's more complex. You have to, in a split second, perceive the stimuli, remember the rule, follow the rule, and then react. And we find even stronger correlations for those type of reaction time tasks than for the simple.
It sounds like playing video games, basically. High IQ.
I have at my former position as a professor, I had students who tested that theory. They actually bought a simple video game that anyone could master with about 10 minutes of practice, gave a intelligence test, and found that the smarter people actually perform better on this video game.
But reaction time, isn't that typically one of those things that tend to increase, or you get worse with age? As you age, you respond slower to, for example, red or green lights in traffic and things like that. So
yes.
So a highly intelligent person of higher age are they as intelligent as someone at the same level but who's younger? How do
That's
you
a very
compare
good question.
intelligence across ages?
Yeah, and this is one of the reasons why on intelligence tests, we do only compare people to their age cohorts, because we don't want to call someone smart just because they're young.
Mm.
And in most cultures, we see wisdom as being associated with greater age. Um, and so you do have to keep that in mind. And different tasks require different mixes of these global or broad or specific accomplishments and abilities. And so this is why the really good intelligence tests have a mix of items. But there are lifespan changes to these different tasks, reaction time, and similar tasks that measure processing speed. They do tend to decay earlier, but there's other measures of intelligence that are very persistent through life. One of the best ones is vocabulary knowledge in a person's native language. That one doesn't decay perceptively until, in healthy people, they're mid to late 80s. And this is why, and it's also very resistant to environmental changes like concussions and brain damage. And it's why when people have strokes, if we're trying to measure their pre-stroke IQ and we don't have that data before they had the stroke, we often just give them a vocabulary test because it's such a good, sturdy measure against injury, against age, etc. And we use that to measure their pre-injury IQ.
There is plenty of books and games and stuff out there that sell the idea that you can raise your IQ. And this is one of the myths I've understood, that basically, correct me if I'm wrong, that once you're a grown up and you're educated and you're healthy, you're not doing anything to damage your brain, that there isn't really much you can do to raise your intelligence as such. You can learn more stuff, you can become more educated or skilled in various areas, but your IQ score pretty much remains the same. Is that correct?
Yeah, you've generally described it correctly. And remember, IQ scores compare people to their age peers,
their age cohort, yeah.
Same age as them. So yeah, you can still learn more, you can still know more than you did 5, 10, 15 years ago. But about between the ages of 7 and 10, someone's IQ compared to their peers does stabilize. That's not saying that that environment doesn't matter. And you had some of the caveats there. Assuming you live in a developed nation, in a non-neglectful environment, assuming you have access to schooling, don't be locked up in a closet for most of your life, then we really don't know how to raise someone's IQ. We can train people in specific tasks. We've known that for generations. And so, we can train people to solve better the specific problems we find on intelligence tests. But training yourself to solve a three-dimensional rotation object, seeing if you can rotate an object in your mind, will not transfer over to being to also solving the verbal questions about synonyms and antonyms. And again, you can teach people the specific tasks and they can improve. Most people aren't taking an intelligence test once and saying, darn, I didn't qualify for Mensa, I need to raise my IQ 15 points, and then engage in a high level training program. Some of these tasks are more trainable than others. And if a test is more loaded with trainable tasks and people start trying to improve them, we can see an improvement in IQ. But that's not, improving your score is not the same thing as improving your general reasoning ability. Just like how I can increase the number on the scale, on my bathroom scale, by grabbing a bunch of books and holding them while I step on the scale, I can make the number go up. That doesn't mean I weigh more. And so, yeah, we can improve the number, but training the ability, training the global intelligence ability seems to be very difficult if you've already gone through school, you're living in a healthy environment, etc.
Now, one question that often comes up is, well, if you're so smart, why aren't you rich? And I wonder, is there any truth to that? Or does IQ correlate with wealth and income on a population scale?
You ask a very good question, one that I've heard also of, hey, if intelligence is so important, why isn't everyone who's smart rich? And it's a really good microcosm for understanding the impact of intelligence on not just economic outcomes, but any life outcome in general. These correlations aren't perfect, and there are multiple causal influences on someone's health, someone's financial well-being, etc. And so, the best way I've heard it described is that higher intelligence makes there's a negative correlation between intelligence and being the victim of a crime. And there's probably a lot of reasons about that, but it doesn't change the fact that when someone breaks into your house or when there's a mugger on the street, they don't stop and say, wait a minute, what's your IQ? And when you say, well, I'm a member of Mensa, my IQ is 145, they say, oh, okay, never mind, and leave your house.
Yeah.
There is always going to be a luck component to these things. And so we're talking about generalities across the population, but it's an increase in probability. So the answer to the question, if you're so smart, why aren't you rich? The answer is there are multiple things that go into intelligence, and a very bright, passionate about their work social worker might make a lot less money than an average intelligence accountant because of different interests, different choices in how they're going to invest their time and their passions. And there's a lot of things that go into an income. Intelligence is just one of those.
I mean, it is one of several reasons people join and stick around in order to find a partner or
and that's one of the most basic social needs, is to find someone to be able to build a long-term relationship with. When spouses or sexual partner have correlated traits, we call that assortative mating, that society's sorting itself out by this trait. Happens with IQ. Actually, it happens with certain other traits too at a stronger rate than IQ, but it does happen with IQ. Like educational attainment. A lot of, in the US, I don't know about other countries, but in the US, a lot of social attitudes. For example, religious people tend to marry other religious people. Atheists tend to marry or form long-term relationships with other atheists, for example. And that's actually a stronger tendency than IQ. So if there's assortative mating out there, it makes sense that in childhood and adolescence, there might be assortative friending. It might be really hard to have a real long-term friendship and natural social connection with someone whose IQ is 20 points below yours. So I could imagine a Mensa member saying, man, my IQ is 145. I wish we were 125, because then that window of people I can easily make friends with would have more people in it. That range would have more people in it. And so, I bet for Mensa members with extremely high IQ, for Mensa members who maybe live in rural areas or in countries where the education system doesn't allow people to develop their abilities as much. I can imagine that would be very lonely. But for most people, and again, children don't have a lot of control over their environment. So it makes sense that if you're very bright in an average classroom, you might be socially isolated, but then when you're put in the gifted class, you can flourish and have all sorts of friends. Yeah.
Which actually, I might add, is, in my personal opinion, one of the strongest, if not the strongest, argument in favor of allowing such classes. It's because of the human aspect. In order to be happy, to have a happy childhood and adolescence, you want to be able to socialize with your peers. You don't want to feel like being the smartest kid in the class. Might feel like fun once or twice, but it gets old. And
it gets old.
You
and that's how I got
to be
sucked
the smartest person in the room.
Yeah, exactly. That's how well, and if you're the smartest person in the room and you love to learn, you're not going to learn much from anyone except the teacher. But that's how I got sucked into this area. Is in graduate school I started doing research in gifted education, and in the United States, most gifted programs don't do much to raise gifted children's academic achievement. They don't actually do much to get these kids to progress faster through school or to learn more than they would otherwise. But one of the really consistent benefits is that social emotional aspect, where a child can say, oh, there are other people like me. I'm not weird anymore.
No.
Or that they can start to take ownership of their giftedness. And it's like, I'm not just a nerd anymore. I can excel at something and be proud of it. I don't have to hide my abilities. For adults, I don't think there's as much of that need because, adults tend to have assortative friending. We have more control of our environment. But there are some people with that need. And if there weren't, there wouldn't be a Mensa. So the existence of your organization tells me, hey, there is that need. I can't deny it.
Yes. And that's ironically, that was something I believe when Mensa was founded, that they discovered pretty much by chance once they started gathering, and they discovered that, hey, it was like the thing that I like to call intellectual resonance, is when two minds vibrate at the same frequency, that something interesting happens. I'm curious about this thing that you call assortative mating or assortative befriending, because isn't it a trend over the last, well, at least 100 years, that our social circles grow larger, and particularly so with the internet, that you're less confined to a small social sphere. It is actually possible for people to find each other across oceans, continents. So I'm wondering, as a scientist, what would happen? What would be the long-term consequences of assortative mating when people can increasingly find each other in larger groups? Is that something that you have looked at?
Yeah, this is a part of a field called behavioral genetics, which intelligence research has benefited a lot from. And we're talking over the course of generations, centuries, for something to actually be noticeable. But yeah, as assortative mating increases for a trait, the more genetically influenced that trait becomes in later generations. Human lifespans, though, are so long that you wouldn't notice this in your grandchildren in your lifetime. But if this were to keep up for hundreds of years, that it would only make intelligence even more influenced by genes. The faster the traits that happens that faster are the ones that already have a strong genetic influence. and the ones that have stronger assortative mating. And so how many generations this would take, et cetera, depends. And then the other big caveat there is that the environment would have to still encourage or allow that assortative mating to happen in the first place.
Mm.
It's hard to get data about this because it's hard to get data to have IQ scores for multiple spouses and their children and to track people across generations. And so it's hard to get good data, but there's anecdotal evidence that, yeah, it is increasing. One of the best sources of anecdotal evidence we get for assortative mating increasing for intelligence is in looking at educational levels and occupations in spouses.
Yes.
In the United States, and in the United States, 100 years ago, the most common occupation was farmer for men. For women, it was domestic duties, often being a homekeeper or a
Probably a fairly
housekeeper or
universal thing.
homemaker.
Yeah.
Yeah, very
Across the world.
Yeah. But as the environments changed, occupation prestige has been much more of a mark of people's intelligence. If you're smart today, you have a lot more options than you did 100 years ago, especially if you're a woman. And so you have to remember that confounding factor. But I saw research studies saying in the United States in the 1960s, the majority of physicians were married to homemakers. Majority of physicians by far were male, and the vast majority of them had spouses who stayed at home as homemakers. Today, the most common occupation for physician spouses is a physician. And if you look beyond just occupational prestige, if you look at actual education levels,
so, couples, both being doctors, basically.
Yep.
Yeah, I think I know a couple.
And the same is going on with lawyers. Lawyers
Yeah.
are marrying lawyers, whereas 60 years ago, a lawyer often married his, and it would always almost be his, secretary, neighbor, person he met at church or something. Today, people are more likely to meet spouses in a work or education setting. And so we have that anecdotal evidence that it's very possible that since the mid 20th century, assortative mating for IQ might be increasing. And over time, that means a more stratified society. It means IQ being even more genetically influenced than it is now. And there are some possible implications to that if the cultural environment allows that to continue for hundreds of years. And I'm sure some smart Mensa member is already getting their science fiction novel ready to explore those consequences. It's changed. Occupation prestige has been much more of a mark of people's intelligence. If you're smart today, you have a lot more options than you did 100 years ago, especially if you're a woman. And so you have to remember that confounding factor. But I saw research studies saying in the United States in the 1960s, the majority of physicians were married to homemakers. Majority of physicians by far were male, and the vast majority of them had spouses who stayed at home as homemakers. Today, the most common occupation for physician spouses is a physician.
Yeah, I think I know a couple.
And the same is going on with lawyers. Lawyers are marrying lawyers, whereas 60 years ago, a lawyer often married his, and it would always almost be his, secretary, neighbor, person he met at church or something. Today, people are more likely to meet spouses in a work or education setting. and so we have that anecdotal evidence that it's very possible that since the mid 20th century, assorted mating for IQ might be increasing.
One thing that I have observed in my own country of Sweden is that cultural and societal attitudes to gifted education have shifted in a more favorable direction. It was something that wasn't supposed to exist at all, except for sports and music. Being good in sports and music, no problem. You can go to a special school for that. You can have entrance tests just to make sure that you get the most talented students for sports or music, but not for other things. And that is changing.
Mm-hmm.
And that has been changing for decades. Slowly, perhaps not as drastically as I myself would have liked to see it, but still, there's a clear change. When I look at the United States, I get the impression that the changes are in the other direction. And that makes me a little worried. Is that correct? That gifted education is coming out of fashion, or that no, everyone should be equal is coming back as an idea?
You bring up several good points. Gifted education is either favored or not. It's very much culturally and nationally dependent. There are some countries that have always been behind it and always driven hard for it. Japan and Singapore are really good examples of that. And with the German high school system that also has, a tier of high school that's much more academic. And there's some countries like Finland where at the college level, the gifted students go for free, and there are many there are a lot fewer resources for other people. There's some developing nations, in sub-Saharan Africa, for example, where they only have the resource to educate 10% of children. So you should concentrate on the most likely kids to reap something out of that. If you don't, you might be wasting resources. So it varies a lot across countries. And you're also right that it varies across time. In the US, we've always had this pendulum where we will reach a point where we say everyone needs to be equal. We are a very egalitarian country. It's in our founding that everyone's created equal. We need to redistribute educational experiences and resources so that everyone has an equal shot. And then it finds that doesn't work as well in practice as in theory. And then we get something where the society wakes up and says, we need to encourage people's abilities. These kids are going to grow up and be our entrepreneurs and our scientists. We need to give them, and then that ends up being unfair and it goes back. In the United States, it's very much a story of shifts in one direction or another across a period of about 20 to 40 years each time.
So if gifted education is going away now, what you're saying is it may come back.
Yeah, it's falling out of favor right now. It's gonna swing back eventually because it already has about 4 times since the field was founded in the 1910s. I look at local context. If I were a Mensa whose child is very bright, maybe even the child's a member of Mensa already, I would be saying more, what are they going to learn? What can I do for my kid? And often that's a grade skip. Often that's a specific educational program that will give them skills that they would not get in other programs. And whether it's called gifted or not, I really don't care.
Which actually, I might add, is, in my personal opinion, one of the strongest, if not the strongest, argument in favor of allowing such classes. It's because of the human aspect. in order
Oh yeah.
to be happy, to have a happy childhood and adolescence. You want to be able to socialize with your peers. You don't want to feel like being the smartest kid in the class might feel like fun once or twice, but it gets old.
That's how well, and if you're the smartest person in the room and you love to learn, you're not going to learn much from anyone except the teacher. But that's how I got sucked into this area. Is in graduate school I started doing research in gifted education, and in the United States, most gifted programs don't do much to raise gifted children's academic achievement. They don't actually do much to get these kids to progress faster through school or to learn more than they would otherwise. But one of the really consistent benefits is that social emotional aspect, where a child can say, oh, there are other people like me. I'm not weird anymore.
No.
Or that they can start to take ownership of their giftedness. And it's like, I'm not just a nerd anymore. I can excel at something and be proud of it. I don't have to hide my abilities. For adults, I don't think there's as much of that need because, you know, adults tend to have a sort of defriending. We have more control of our environment. But there are some people with that need. And if there weren't, there wouldn't be a Mensa. So the existence of your organization tells me, hey, there is that need. I can't deny it.
We talked about a correlation between reaction speed and intelligence. I believe there is also a correlation between working memory, like how much you can hold, how many items you can hold in your head, and intelligence. And there are tests for that, I believe.
Yes.
What about other kinds of memory, like episodic memory, how you remember events from your life, or what if you remember what you had for breakfast, assuming you don't have porridge every morning, but you know, those kinds of things. Does that also connect to intelligence?
Theoretically, it should. But working memory is actually very easy to measure. We usually use a task called digit span, where you repeat it. This might sound familiar to a lot of Mensa members. The psychologist gives a verbal list of numbers, and the examinee has to repeat them back in the same order. Sometimes they have to reverse them and repeat back the numbers in the reverse order, which is actually harder. And sometimes there's other versions of this, and that measures, people's ability to keep multiple ideas in their head at the same time and to manage those. That's working memory.
You explain in the book about physical correlations in the brain. Although I think the strongest point that you make, as I picked it up, was that there needs to be more research done in that field. But that we know, or we ought to know, that there is some form of connection between structures in the brain, characteristics of the brain as a physical organ, and its performance, intelligence. One such being size. Also one such being the organization of the brain cells themselves. In a more, I guess this is where we would need a picture. Maybe we can put up the picture here while we're talking. Brain cells of highly intelligent people have fewer, what did you call them?
They have fewer what we call
neurites,
dendrites
that extend from the body of the cell.
Which was a big surprise to neuroscientists. People thought, well, you would want a brain cell that extends out in as many directions as possible, and has as many possible cells that it can send a message to, and that doesn't seem to be the case. I mean, when I saw that study about 5 or 6 years ago come out, I was floored. I said, this one study is more important than everything I'll ever do in my career. And my colleague Aaron Gensch was the lead author on that. Yeah, he found that that there are actually fewer branches off of smart people's brain cells than there are for average or less intelligent people. And so that seems to be evidence that it's not just the structure of a brain that matters, it's also how that brain is organized. And so his theory is that what's going on is that even at the cellular level, at the microscopic level, a smarter brain is better organized. And so just having a lot of brain matter does seem to help, but also the way it's organized and the way it functions matters a lot too. You're right, though, that that the research on the neuroscience of intelligence, it's progressing. We have now some really good theories to guide work, to organize our findings, to suggest questions, and a lot of those theories are being strengthened over time. But there's still a lot we don't know about why some brains can solve problems better than others, and it's a real, when you think about it, it's a really complex problem. Your neuron in your brain does not see the intelligence test question. It does not literally know that you are being asked whether two words are synonyms in your native language. And so to go from a neuron somewhere deep in your brain that can't see anything, that can't think independently, all it does is send and receive electrochemical signals. To go from that to a person who can solve problems, sometimes very abstract problems that don't have a well-defined solution. That's a hard thing to do, and we're just barely starting to understand how we go from the cellular level to the behavioral level.
On the topic of physical aspects or structures in the brain, there's a claim I've seen that IQ scores correlate with a number of synapses, but I haven't been able to find the source of that statement. Is this true?
I don't know about synapses specifically, and
synapses being
yeah, I know it's
as you obviously know, but in case the viewer doesn't, the connections between the neurons in the brain.
That's what I was going to say. The little branches, the dendrites on one neuron meeting the axon of another, they actually don't touch. There's a small gap between them. There's a little small gap between my fingers. And that gap is called a synapse. And so a synapse is not a physical object. It's actually a gap between objects. And it's actually really hard to count them in a brain, because you have, at least theoretically, a geometrically increasing possible number of synapses. So two cells can only have one synapse between them, but three cells can have three synapses among them, because each cell can touch the other two. Yeah,
each side of a triangle.
Exactly. Four, I gotta make sure I get this right. Four of them can actually have, so your 3 + 2 + 1 can actually have 6 synapses.
Yeah.
5 can have 10 synapses. And so the number of possible synapses increases way faster than the actual number of neurons. And when you consider that there are billions of neurons in a human brain, the theoretical number of possible synapses, it just becomes mind-boggling. It's probably
is way higher than anything that could be physically possible.
Probably in the quadrillions, at least theoretically. but not every cell connects to every other cell in a brain. Some connections are very local, where neighboring cells will be able to communicate. Some cells communicate with other cells at the complete other side of a brain, and it's very hard to actually count the number of synapses out there. What we do know is the number of neurons, the actual cells, that the more neurons a person has, the higher intelligence they tend to be. And that might be one of the reasons why brain size is also positively correlated with intelligence. And so I can't speak about that claim about synapses specifically. It would be a very hard claim to verify with current methods and technology. But hopefully one day we can verify that much better. But until then, we have to be satisfied with number of cells, how organized they are, how well they function, etc.
On that topic, because it seems that intelligence is an emergent phenomenon that arises out of the collective action of all these billions of neurons. So one way of looking at that would be to say that intelligence comes from, it's not from the neurons themselves, but rather from between them, or from them working together. So I have a brain, you have a brain. How can two people become smarter together? It would seem that, well, there's an obvious answer. I mean, collaboration, two people can accomplish more than one person. But that doesn't seem to be the case when it comes to intelligence tests. Or is there a way for a group of people taking a test to outperform if they were to take these tests individually? Do you understand my question?
Yeah, it depends on how a group is set up, and it depends on the components of a group. If it's just, a simple, if like a good example that's extreme where the group won't improve at all is if, yes, they're a group, but they're just physically in the room solving problems independently. They don't work together, and then the group average is going to be the overall group score. No, they're not going to outperform the smartest person in that group. But you can set up groups so that the group's problem solving performance is better than any one individual's. This is especially true with multidisciplinary problems.
But that's because you have a knowledge component, right?
And that's exactly why, yes.
Yeah, that's exactly why. So when you have the knowledge component being stripped out, as in a properly designed intelligence test, is there a way for, can you take people scoring, say, 100 or 120, if you have a sufficient number of people, IQ 120, can they reach a score of 140 simply by collaborating?
Possibly if they collaborate, and if their knowledge and those broad mid-level or those specific skills are different enough, and if they have a collaborative environment and time, yes.
But has it been done?
What?
Has this been done, or is it, you say possibly, but has there been experiments? Is there any cases?
There have been, and a lot of it is very dependent on how groups are set up and structured, and a lot of it is dependent on the questions themselves. Intelligence test questions, because we really like tasks that measure intelligence very well and don't measure other things very well. The group dynamic tends to not be very important, but gives someone a practical problem to solve. A good example is launching satellites into orbit. 70 years ago, no one had ever done that. Having that interdisciplinary team could be very, very useful and can solve problems that an individual can't. It also depends on how the group is set up. If I can be really flippant and insensitive,
Go ahead.
If you have a dumb dictator running the group who can veto any idea, that's not going to be helpful. But if it's a collaborative group where people are allowed to express dissent, they're allowed to check one another's work, present arguments, and decisions are made rationally, democratically, with people recognizing where expertise are or are not. Yes, that can be a very healthy group that can solve problems way better than an individual can.
So that makes sense. But being given more time, for example, to solve a problem or to solve a test, like the intelligence tests that I've seen, is that usually there are a bunch of really hard questions there, and you get the feeling that you either solve them fairly quickly after having seen them, or you can sit and look at those problems for 10 minutes and you still don't get it. So by doubling the time or tripling the time, or wouldn't really make much of a difference. Is that the case also in your?
Yeah, most time limits, and people have done research on what happens to scores if you remove the time limit, except for tasks where you give people a bonus for finishing quickly, or tasks that measure speed in and of themselves, like processing speed, reaction time. Putting those to the side, giving people unlimited time does not impact their score very much. And for most tests, this isn't just true with intelligence tests, this is also true with academic tests that are given in school. Often the time limit's just there for practical administration purposes.
Thinking of metaphors that people use for intelligence, and as I understood, the intelligence being one thing instead of many things means that I should probably retire my Swiss Army knife metaphor that I have sometimes used, in that you can have the screwdriver, knife, fork, cork opener, etc., and that you have all of that in your brain. But if it's just one thing, what you who have studied this in depth with other people, what do you view intelligence as being, if you were going to pick a metaphor from regular life? Clock frequency or voltage?
That's a very hard question, and it's one that literally for over 100 years psychologists have been trying to get a good metaphor. Charles Spearman, one of the pioneers of the field, said that intelligence was mental energy. His metaphor was, it's the coal that you shovel into the locomotive's steam engine. We know that that's not true, because if that were true, as the brain had more energy at its disposal, IQ scores would go up, and as you got hungry or your blood glucose level dropped, your intelligence would go down. It doesn't happen that way.
Yeah.
And then when scientists discovered how neurons communicate with one another, the brain is like a telegraph system. Electrical impulses going down the wire. And then we discover, well, no, there's a chemical component, and it's more complex. And then
computer and hologram.
Yeah, exactly.
Like the internet.
Yeah, the computers are invented. Oh, the brain is like a computer, and in some ways it is, but no, it's not. And now, right now the current fashionable metaphor is that the brain is like the internet, and no, the brain is not like an internet. And you know what's going to happen? In 50 years, there's going to be some really amazing technological invention. And my grandchildren will be sitting in a psychology class, and that professor will say, the brain is like a Zagadorp, this new amazing thing that hasn't been invented yet. And everyone's going to nod along, and no, the brain's not going to be like that. The brain is like a brain.
The brain is like a brain.
And psychologists are really guilty of looking at technological inventions and saying, wow, that's amazing. The brain must be like that. And it's not. So I think any metaphor is going to fall short because the human brain is the most complex object ever discovered in the universe, at least by humans. So I think metaphors are going to fall short because they're not going to capture that complexity. And you could retort to me and say, well, metaphors aren't supposed to capture everything. They're supposed to be a good metaphor. Okay, fine.
Well, a metaphor can help understanding, but it also constrains understanding.
Exactly.
Making us see the telegraph instead of the real thing.
And so my best understanding, and I do sometimes contemplate this, is that maybe intelligence might just be what the brain does. That just like how the liver metabolizes different materials and the kidneys clean out waste from the blood system, maybe the intelligence is just what a brain does. Maybe that's its whole function. And then once you have a species that evolves to the point where it does more than just that brain does more than just meet physiological needs and respond to stimuli, maybe you get this emergent property of consciousness. Maybe you get this emergent property of problem solving that can be applied to things that that evolution did not I don't want to say plan for, because by definition evolution
like literacy, the written language, for example.
Yeah,
the capacity of the brain to handle written words.
So yeah, the Swiss Army knife it's a good metaphor of, hey, look, here's this ability that can help you do a lot of different things. So the Swiss Army knife metaphor is a good metaphor for how intelligence can help people. It's this general ability that can help you do specific tasks. A Swiss Army knife's a general tool that can help you do specific things. But any metaphor is going to be imperfect, and the Swiss Army knife metaphor doesn't capture what intelligence is. It captures what it can do, but not what it is. And so I hope you can hear how unsatisfied I am with my own answer. I really don't like the answer of intelligence is what the brain does. I don't like that because it feels like an answer that doesn't answer anything.
No, but
it's actually a pretty bad metaphor because I feel like it doesn't reveal anything.
No, but if that's the case, then it would have to be true for any kind of brain. It's not just a human brain that is intelligent. A chicken has a brain that is also intelligent up to some point, and even the smallest creature, it does perform some form of processing information from its environment, using that to make decision one way or other.
And I've seen people make that argument that in non-human animals, that their nervous systems, especially their central nervous systems, if they have one, that in non-human animals, we should make an argument and recognize that being able to respond to stimuli, even if it's as simple as a light source, that is a measure of intelligence in that species. And I think that's a very compelling argument.
Yes.
And so, you asked me one of the hardest questions out there. Well, what's a good metaphor? And, I give what's probably the least satisfying answer possible. Intelligence is what the brain does.
I'm going to give you a simpler question, and we can
Thank you.
wrap up the interview with this one. You have listed 35 myths about human intelligence in your book. Which of these 35 myths do you find to be the most damaging one, the most harmful one, the most urgent one to debunk?
That is not an easy question. Don't lie to me and say you're going to wrap up with an easier question.
Okay, I'm going to wrap up with a tricky question here.
I think it depends on who's believing them and the audience. One of the myths, for example, in chapter 18 is every child is gifted. If a teacher or a principal believes that, that's an extremely damaging myth. No, not every child is gifted. Some are smarter than others. Some can do math better than others. If you include,
I think those who say that do it with the best of intentions, in the sense that,
and a lot of these myths have good intentions behind them, or they have a small grain of truth that people overgeneralize or misunderstand. So I think what's most damaging, I think it depends on context. And it depends on who. A teacher who thinks that every child is gifted, and so I'm not going to do anything special for the kindergartner who already knows how to read. I think that's horribly damaging to that child. But if my neighbor who's a sculptor believes that, I don't really think it's a big deal, because his belief doesn't have really any consequences for anyone except for maybe possibly his own children. And so I think it depends on who. In the United States right now, one of the more damaging ones that I see is just denying the genetic basis of behavior in general, not just intelligence. Almost every psychological trait or behavior does have a genetic influence. And so I think denying the underlying genetics of human behavior leads to a great deal of societal confusion, societal waste, and in that this can lead to a lot of actual suffering. This is true whether people deny, for example, a genetic basis to homosexuality. And so they try to look for therapies to cure their child or themselves of their same-sex attraction. I think that can be very damaging. Well, just as that can be damaging to people, I find the denial of a genetic basis of intelligence very damaging, because then we start blaming a child when they can't master algebra. Oh, you must not have studied. Oh, the parents didn't help them with their homework. Or you start blaming other people. Oh, the schools aren't funded well enough. Oh, the teacher isn't very good at his job or her job. And so I get very scared when people deny the genetic influences on any behavior or psychological trait, because then I think it starts leading to waste, it starts leading to suffering, it starts leading to very ineffectual solutions. And so
could the damaging belief there be that the fear that, well, if we are controlled by our genetic makeup, then that's the end of story. There's nothing we can do about it. But from what I understand, and also what you write, and well, what you have inherited, your genes, is a starting point. Everything else comes later, and it all depends on what you do with this in life. So acknowledging that there is such a thing as DNA that actually does influence pretty much everything. As you say, the keyword is influence. It doesn't determine.
Exactly. So. And that's what I think people need. And I think genetic influences do scare a lot of people, because they imagine the movie Gattaca, or they feel like it's so limiting. But you have to remember, a gene is just a piece of it's just a segment of DNA. It's just a piece of protein. Just like how the neurons can't see the intelligence test questions, and the DNA is not whispering the answer into Mensa members' ears and getting them to answer a lot of these questions correctly. You're right. It's just a starting point, and we need good environments to help people develop their full potential. You can have the DNA to be the smartest person in the world, but if you never go to school and you're locked in a closet for your entire childhood, you're not going to be the smartest person in the world. But the flip side of the coin is there are some people who, even with the best environment possible and the best training, the best teachers, they are never going to master calculus. And I think it's okay.
It's okay.
It's okay. We need all types in society.
Yes. You make a very strong point at the very end of your book that I found actually to be quite moving, where you write, I will read this. Finally, I invite my readers to make an effort to associate with people from different IQ levels. Make friends with people with low prestige jobs at your workplace. Volunteer in places that will increase your likelihood of interacting with people with lower intelligence, such as a prison or a charity that helps people with intellectual disabilities live independently. And assuming that most people who will be watching this are likely people with an interest in intelligence, and most likely people with higher than average intelligence, I think that's I like that invitation that you give to us all to reach out and not just socialize. Having said that, Mensa, of course, if you want to socialize with people who have an intelligence in the top 2% of the normal distribution, we have chapters in some 50 countries. We organize regular test sessions. So if you are interested in finding out more about your own intelligence level or finding a group somewhere, please go to our website and you can find more information there.
Yep, and I think there needs to be both. I think not just with IQ, but with any trait. You know, there is a time when you need to associate with people like you and let your hair down and relax. And then there's a time when it's beneficial to mingle with people who aren't like yourself. And so yeah, there's definitely a place for Mensa. I'm really happy with the work they do. I had never ever tried to join, and now that I have answer keys to IQ to intelligence tests, I can't join.
Don't worry.
I appreciate, you know, what Mensa does in touting the importance of IQ and intelligence, and I appreciate the social outlet they give to people. And you know, it sounds like a great organization. I'm an admirer of the work they do, and you know, it has a lot of staying power. You know, 75 years, like you said. That's pretty impressive. You don't last 75 years and become an international organization with hundreds of chapters without doing something right. So yeah,
we must have done something right. And the big plan, of course, is to last for another 75 at least, and see what comes next in our future.
Good luck.
It's been great talking with you,
Nice talking
Dr.
with you too,
Russell T. Warne, and many thanks.